Okay, so as you can see, you've probably noticed there are some kind of step things, and you're probably wondering what even are these. So this is how we divide the periodic table accordingly, so that you have metals on the left and non-metals on the right. There is no reason that there's one on the right and one on the left. It's just this happens to be that metals are on the left and non-metals are on the right. And as you can tell, there are way more metals than there are non-metals. However, you don't always just have metals and non-metals. There are these things called metalloids. As you can see here, I have told you which ones are metalloids. So it's boron, silicon, germanium, arsenic, antimony, and tellurium. So these display characteristics from both metallic and non-metallic things. So they could be shiny, they could be good conductors like these on the non-metallic side, but it's not really, it's just, they can't really decide what they want to be, metallic or non-metallic, but they are known as metalloids. You've probably noticed that the numbers on the bottom of each element, so 1, 2, 3, 4, are all going up. These numbers in this periodic table from the Royal Society of Chemistry are the atomic numbers. So 1 proton, 11 protons with sodium, 19 with potassium. So the periodic table is set or organized, we should say, so that the size of the atom is increasing. This is quite obvious that the size of the atom is increasing because the atomic number is increasing, and you guys know that the atomic number shows you how many protons are within the nucleus. So the nucleus must be bigger if you have 11 protons over like 1 proton, which is in hydrogen. Okay, so here is another periodic table that, as you can see here, so I've put 1 here. So 1 means that this is a group. So going down is a group. So this is known as group 1. Okay, group 2 going downwards. So beryllium, magnesium, they are group 2 going all the way down. And then we skip all of these elements that are in the blue, and we jump right over to the elements in the green, and this is known as group 3. Purple, group 4. Grey, group 5. Orange, group 6. More of a reddy orange is group 7. And this mustardy khaki type colour is known as group 8. You may see in some periodic tables that this is group 0, but we'll go with group 8. Okay, and then I've placed 1 by here. So going all the way across, so hydrogen and helium. This is a period. So going down is a group, going across is a period. So if you just like try to think about it maybe as like a period of time, you're going along. So yeah, maybe that will help you remember that going along the periodic table is a period. So again, number 1 on the top, and then we'll go for period 2, starting with lithium, ending with neon, and period 3, which is starting with sodium and ending with argon. Oh, and you also need to know period 4, which is starting with potassium, ending with krypton. Okay, so then over here, I will further discuss this in more detail. But as you can see, you have the hydrogen, and we, instead of including the protons within hydrogen, I've just placed a H in the nucleus so that you guys should be able to work out, if you look at your periodic table, how many protons and neutrons are within this nucleus. And then you can see here that there is 1 electron in the first shell. We call this a subshell. So then you've got helium again. you guys should be able to work out what's in this nucleus where I've placed He. And then you have 2 electrons. Beryllium, again, you guys should be able to work this out. So if you have 4 here, you have 4 protons inside. 9 minus 4, sorry, is 5. So you'd have 5 neutrons, sorry. And then again, you have the same number of electrons as you do protons. So nitrogen here, you can see, and aluminium. Okay, you guys are probably wondering what even are these numbers that I've got in colours. So here I'm going to tell you. So first of all, the first number, which is I've placed always in blue, here is number 2. So this represents the first shell. You can only fill the first shell with up to a maximum of 2 electrons. Okay, this is a rule, you need to accept it. You always fill the first shell with 2 electrons. This number so also tells you what it could tell you, like what period the atom is in, or the element. So as you can see here, hydrogen, 1 electron. So you would place number 1 because it's only occupying, there's only 1 electron occupying that first shell. So number 1. So it must be in period 1 because there's no more to it. And then you have helium as well. Again, in the first, we call this a subshell, in the first subshell. So again, it's at a maximum capacity. So it must be in period 1 because there are no more subshells filled. So there are no more electrons available to be able to say that this element is in a higher period number. Okay, so next we fill up the second subshell, which is filled up to a maximum capacity of 8. Okay, and guys, you have to have filled the first subshell. So this has to be 2 before you can think about putting any number in this one, okay? So the second subshell will tell you that the element is in the second period of the periodic table. And as you can see, I've said that it can occupy 8 electrons, but you have to have filled this first subshell first. I can't stress that enough. Then we move on to the third number, which again, you fill up to a maximum capacity of 8 electrons. Just like filling this one, the second subshell, you have to have filled both of these before you can even consider including electrons in the third subshell. If there are electrons present in the third subshell, then this tells you that they are in the third group. So if we look 283, so it's got to be in the third period because there's 1, 2, 3 numbers, okay? So 3 subshells have electrons occupying them. So then we know which element it is, so it's aluminium. So if we go over here and check, look, oh, let's go to period 1, period 2, period 3. Oh, look, it's here. Okay, and I'm literally about to tell you how you can work out what groups the elements are in as well. But anyway, let's move on to here. So you have another 2, and this is known as the fourth subshell. And this can only occupy 2 electrons again, okay? No more. So again, all 3 subshells before need to be filled before you can even think about putting anything in the fourth shell. And this shell, if there are any electrons within this shell, you know straight away that it's in period 4. Okay, and you guys only need to go up to the element 20, okay, which is calcium. So you guys need to be able to mix, like, you guys need to be able to draw these structures for the first 20 elements. And it's really easy if you think about it, guys, if you just follow these rules. So you just need to remember 2882. So first shell, second shell, third shell, fourth shell, period. Oh, sorry. Period 1, period 2, period 3, period 4. Okay? Right then. So if you look at the final number, okay, of within the electron configuration, that's what we call this number, the electron configuration. So it's just telling you where the electrons go, okay? So that's what we're talking about here. So if you look here, the final number in the electron configuration is 1, and there is only one number. So we know that it must be, this element must be in period 1, but also it's in group 1. So if we go over here, period 1, yeah, oh, and oh look, hydrogen, group 1. And if we look at, say, aluminium, so you have 1, 2, 3 shells, so you know 100% this is in period 3. And then you look at the final number, ooh, number 3. So it's got to be in group 3. Okay, so we have 3 numbers, so period 1, period 2, period 3. And if we go over to group 3, which is here, oh look, aluminium. Again, we'll try this with beryllium. So 1, 2, so it's in group 2. The final number is number 2. So it's got to be in it's in period 2 because there's 2 numbers. And it's got to be in group 2 because that's the final number. So if we go to group 2 first, so 1, 2. Oh, this is period 1 and this is period 2. Oh, would you look at that? We have beryllium again. And you can try that with any of the first 20 elements. I urge you guys to try it. There will be worksheets available. But yes, so you can literally find out what the name of any element is if you have the mass number and the atomic number. That's all you need for this, to be able to do the electron configuration, but also draw out the structures. Okay.